Alright, so this is an application of differentiation question sent to me by a Year 12 Maths Methods student. So we've got y equals 2x minus 1 all to the power of n, and that's multiplied by x plus 2. And we want to find the x-coordinates for all stationary points in terms of n. N looks a bit like an x. Okay, so we're asked to be doing differentiation. We're wanting a stationary point, so we're going to differentiate this function. So we have the product of two functions. In this case, we have this function multiplied by this function. So if we want to differentiate the product of two functions, it is the derivative of one times the other plus the derivative of the other times the first one. So let's define our functions. So we're going to say u is 2x minus 1 to the n, and v is x plus 2. Just realized I forgot, n is a natural number. Okay, so it's a whole number, and it's positive. Alright, so for our u prime, we're going to need to use our chain rule. So what do? We differentiate what's in the brackets. That goes out the front, so that becomes 2. We then bring our power down, so n comes here. We have the function that's in the brackets, and we reduce that power by 1. So n minus 1, we've differentiated. This n comes from following that rule. So hopefully you know the rule. D dx, x to the n, is nx to the n minus 1. Derivative of x plus 2 is 1. Now we apply our product rule by cross multiplying. So that times that, followed by that times that. So we get y dx is 2x minus 1 to the n plus 2n, 2x minus 1 to the n minus 1 times x plus 2. So x plus 2 times that guy, and 2x minus 1 to the n times 1. Now we want the stationary points. What's the definition of a stationary point? A stationary point is such that y dx equals 0. So let's solve this guy for 0. So let's say that 0 is equal to 2x minus 1 to the n plus 2n, 2x minus 1 to the n minus 1, x plus 2. Do we see a common factor? Hopefully we do. We'll notice that here we've got 2x to the n, and here we also have 2x to the n. So we can take that factor out. So we get 2x minus 1 to the n times 1 plus 2n, 2x minus 1 to the negative 1, x plus 2. So that times 1 is that, and this next term would increase this power by n using my index laws. So now, null factor. If a times b is 0, a equals 0, or b equals 0. So that means I have 2x minus 1 to the n equals 0, or 1 plus 2 to the n, 2x minus 1 to the negative 1, x plus 2 equals 0. Because this thing equals 0, if I raise both powers both sides to the 1 on n. Of 0 to the 1 on n is just 0, so I get 2x minus 1 equals 0, x equals 1/2. So that's my first stationary point. There's a stationary point at x equals 1/2. Now, this is actually in terms of n. Okay? Give yourself a second to think about that. But I could just add plus 0n to it, and that's in terms of n. So that half is still a valid solution for this question. Now for this next one, we're going to have to do some algebra. So let's tidy it up a little bit. Let's move the 1 across to the other side, and let's deal with this negative power. So I'm going to have 2 times n, x plus 2 over 2x minus 1 equals negative 1. So negative power means I'm at the denominator, and I've moved this negative 1, this 1 across to make it a negative. Now let's get rid of that fraction. 2n x plus 2 equals negative 1 times 2x minus 1. So I've just multiplied by this denominator. I'm going to expand all my brackets now. I get 2n to the x plus 4n equals negative 2x plus 1. I'm going to group all my like terms. I'm going to move all my x's over to one side and everything that's not got an x over to the other side. So I'll get 2nx plus 2x equals negative 4n plus 1. I can factor out my x, so I get x 2n plus 2 equals negative 4n plus 1. And I can divide both sides by 2n plus 2 to get negative 4n plus 1 over 2n plus 2. So my stationary points, so my x chord for stationary points are x chords, x equals 1/2 and negative 4n plus 1 over 2n plus 2. Okay, that's it. Good luck.